So today, this morning, going to view starting from lab module 1A, 1B, and then we proceed to the final one, 1C. So looking at module 1C, this one is related to PTK48. So what is PTK48? It is a training kit. So training kit, you're going to do this on the second half of this semester. So I will just give brief introduction. So later on, when you come back to UNIMAP, doing this lab, so we're going to go deeper and start working with the training kit. So for today's objective, we're going to have introduction on the kit. So the lab session for the lab 1 session is all about giving you introduction. So there's no need to submit any report for lab module 1, 1A, 1B, 1C. No need to submit anything. However, there are exercises available on each of the module. For information 6, you are encouraged to try the exercise so that you can experience using the software and you have some general knowledge basic to do later on lab session, especially lab 2, 3, and 4. For lab 2, 3, and 4, we're going to do submit report in a group consists of two members. So look at the components required. Everything here except for this one. Here is two software, and then a computer unit. So MPLAB IDE. This one is an older version of compiler. So currently we are using XC8. Like this one, XC8 compiler. So do not be confused. So later on we will update this one. Okay, so these are the component required. So we have two software. This one compiler XC8, and then the IDE, MPLAB IDE, and then the training kit, PTK40A, PIC training kit. So what is PTK40A training kit? PTK40A is a training board. So this one work properly on 8-bit 40-pin DIP, DIP type PIC microcontroller. Okay, so only suitable for 8-bit. Other than that, we will see later whether all application, all type of microcontroller can be applied or certain model. So see the second one, it is compatible between 16F and also PIC18F. So these two type of model can be supported. You can connect to PTK40A. So the kit can cover programming, interfacing, and application of microcontroller. So basically, the kit you can work together. It can work together with programming. You can interface with the PC, and it is also contain mechanical hardware so that the user can easily understand, observe the output of the program in PIC microcontroller. So it can be configured to be programmed to any available languages such as Assembly, Basic, and C. So you're going to program the kit using MPLAB that is written in C language. So MPLAB IDE included to come together with this kit. So you can do at the same time. You can write, develop a program. Okay, so the proposed language, the preferred language is C. Okay, so once you have developed, and then you can link with MPLAB to the kit. and then you can observe the output of your program. So how to link? So basically, the next one, if you see the figure here, it is also included with an USB ICSP PIC programmer. We call it UI C00B. So this is 21. This is the mentioned programmer. So it is also come together with the software. Okay, so using this programmer, you can link develop program with the kit. Okay? But between that, you need to program using this programmer. So every programmer comes together with this kit. So you just download, program, and then you can observe the output. So you can see here. Okay, so there are many modules, many functions that you can develop using this kit. So looking at this, you can see, you can simulate. You can observe the output of keypad, LCD, motor control. We have stepper motor, we have servo motor, so DC motor. And then this one, we can observe, so monitor and also control relay output. So this relay can be connected to any load that is available. And then this one, LEDs, you can observe, program, develop using MPLAB, and then you can watch the output here. And then this one for testing of ADC, and also 7 segment. And then this part would be the supply part. So everything, the basic function included in this kit. So when on the second half of the semester, you're going to experience this. So if you refer to this figure, every function, every component is labeled. So you can see the definition by looking at this table. Okay, so how do we use this item? It's just basic, because you're going to do this later on. So just a basic, just to give you some knowledge on how to operate this kit. So looking at part A, how to use it. The first step would be to load program into PIC microcontroller. So you can only use this kit once you have developed the program. So how to do that? The first thing, this is a USB cable, micro USB cable. That one is already available in our lab. So you need to connect this cable with this programmer, and then the other end you need to connect to USB input of the PC. And then at the same time, so you're looking at this top, this one need to be connected to an external power supply adapter. Okay, so already available at our lab. So you need, in order to function properly, you need to supply power using this socket. Okay, and then this is a switch. Once you have completely connect the kit, you need to switch on, and then connect USB mini cable, this one, okay, to this kit, to the programmer actually. So since the programmer assemble together with the kit, so you just connect using the USB cable, and then switch on power supply. Okay, so you switch on with the flow shown here, and then launch PIC to kit programmer by selecting this one on the window. Okay, so this is what the software looks like. Later on you will see. Once you have complete the hardware part, you go to PIC kit. So this one need to work together with the programmer. So in order to program any program, you can use software. Okay, there are other alternatives available. Later on I will discuss the alternative. So when the PIC toolkit programmer application is first, it will attempt to identify connected device. So when you execute for the first time, it will try to communicate, okay, and then try to identify which type of microcontroller being used right now. So you can see from here, the device, the microcontroller is PIC 67F877A, and then user ID, and then some statement, some information regarding the connection status. And then to connect a device to application, so running. So to whenever the application is running, you can use this procedure, starting by going to tools here, tools, and then check communication. So if you are doing this correct, new indicator, that one you see later on, stating that the connection is enabled. So the function is very limited, just to program, to communicate with the programmer, to program the code, the hexa. So previously in our class, we are using MPLAB IDE, write down our code, and then if we compile, and then when we compile, if the program is success, a new file will be created in the format of extension .hex, hexadecimal. So that one, that is the file that you're going to use whenever you want to program your program with the IC programmer. So the file must be in the form of hex, okay, that need to be programmed. This one is 40A. Okay, so you go to file, file here, okay, and then locate where is the location of that particular hex file. And then once you find it, click it to open, and then code will be displayed in the form of memory, program memory, and EEPROM data window. So before you proceed to anything, make sure that the model is correct, then the connection has been established, so you can go to writing the program. So if success, so you can see here indicator stating that the programming between the program and the PIC has been successfully established. So this is the basic part. Okay, so how to about using the kit. So when you download, when you program successfully, LCD will display instruction to test all the component of board. So this one may refer to the program, test program. Okay. So and then you observe the LCD, and then you need to follow several instructions print on the LCD. Okay. So make sure that mini jumper connection is correct. So on the test program, according to the number of menu that you have key in, so you need to make sure that connection for that particular program is properly connected, so that you can observe why. If you refer to the last session appendix A schematic, so you can see this is the microcontroller. So like I said last time, certain pin on PIC microcontroller, they are sharing certain function. Okay? Like for example, ADC and digital input output, so they are sharing the same function. So that one within the microcontroller, but the hardware also are sharing same pin. So you need to identify switch jumper. So this jumper will act as a switch. So you can see it, you can locate the jumper here, okay, 31. If you don't know, you can check the number pin selector. So if the program is running to control motor, okay, which type of motor, let's say program is running on servo motor, so you need to configure the switch so that the program could be directly connected to the servo. And then the other type of program, you need to view on the LCD part. So that one conclude. That one conclude for briefing using PTK48. So do you have any question related to PTK48? Ada soalan tak? Nak tanya berkaitan dengan PTK48. This is lab module 1B. Some of the function, some of the manual instruction related to previously mentioned module, which is involving PTK48. So in order to view, to do simulation, we need to refer to module 1C. So the objective is similar to previous one. We want to introduce the software MPLAB X IDE and also XC8 compiler to work together with microchip microcontroller. So equipment use stay the same. MPLAB X IDE and then XC8 and then computer unit that contain this software. So what is a MPLAB X IDE? It is actually a software. So it can run with Windows, Mac, and also Linux. So you can develop any program, okay? Any signal digital controller, any load, connected to sensor. You can do everything within the specific function of the particular microcontroller using MPLAB IDE. So what is IDE? IDE, we call it Integrated Development Environment IDE. Why? Because it provides single integrated environment in developing the program. Not only that, you will also be able to debug the program. You can also communicate with the programmer directly, program the PIC. You can observe the output. You can observe the output through debugging process. So it can work unlike previous version completely in-house. So the previous version developed in-house, but the new one is an open source. Okay. No need to worry about buying the software. You can download freely. So because of open source and a lot of support coming from this company who is developing the software, so the function improve so that the purpose of making easy, quickly can be established. So the MPLAB, the software, can work together with 8-bit of PIC, 16-bit, and 32-bit. But for different type, they need to have their own specific compiler. So for 8-bit, which is a PIC 16F, you need to use XC8. Other than that, for 16, you can use it with 16-bit PIC microcontroller, and so DSPIC, PIC 18F, and then the other one is PIC 24, okay, and the later on model. And then for 32-bit, more advanced microcontroller, 32-bit, the respective compiler is XC32 or 32++. So you can use some of the function that you can see here. Everything can be represented in the form of graphical. So you can edit, you can view the function, the specific function, command present in terms of icon. The program also color coded. So everything graphically, so that the programmer will be easy to program the microcontroller. So how do we start? So you go first to part A, so you need to click. If you refer this one, this is the icon when you have installed the software. Okay, this is the icon that will execute MPLAB X IDE. So ignore others of icon that is not related to this software. So you double click, and then the screen here will appear. This one will appear, and then this is the loading progress. So if the loading completed, so new window, the main window will appear. Okay, so you need to wait first. Better computer, sophisticated computer, advanced computer, the speed is faster. So need to wait. And this is the main window environment. You can see here the version. You refer the version. This is the current version that I am using, version 6.00. Okay, so this one is what happen when you execute the software. And then this the information, the next one. If you are using PIC SimLab, so better once you have the software has been uploaded successfully, you double click execute PIC SimLab if you want to use. Okay, so this one is an example. Okay, so you can see the order is execute nplab xide first, and then once the window appear, okay, then you can go to click PIC SimLab. The order must be starting with nplab, and then you go for PIC SimLab. Okay, so we go to the next one. So you can see this is the environment. So you can see if you refer to the model version number. Okay, so for the manual, the model is older version 4.10. So you can expect some function between the latest and the oldest might be different. Certain function might not be included on the lower version, older version. You can only access on the new version. That one will be seen later. So once you have successfully execute, and then loading introduction window screen will appear, and then this is the main window. So in order to create code that is executable by the PIC microcontroller, so we need to put the source file into a project. So whenever you want to start any coding, you need to put the source file into a project. So the first thing to do is create a project. One project for one program. Okay. So the code using the source file written on this source file can be executed using selected language. So for our scope would be C language. Okay. So other type of language available, assembly, and then what type of compiler, what type of linker, and so on. This one we will see later. Since we are using PIC 8-bit, 16F, so the compiler, the correct compiler you need to specify would be XC8. Okay, so you need to install together. It is PLFX. Okay, so how to create the project? These are the basic function that I will explain. Okay. The first one on creating the project. So this is the first thing that you need to do before you do any program development. Start by create a project and then select language, whether C, assembly, basic, and so on. And then how to put files in the project. This is the file that you're going to be written with your code C language. So the project, when the project exists, you still need to add a file. So the file contains code that you are developing. Okay? So without the file, you cannot write anything. Then create code. Okay, so this is based from previous lab. You write code according to the function that you are desired according to the program output. And then build project. This is how we compile by checking the status of our program. Check whether the program is correct, and then if the program is correctly written, so it will cause the compiler to create, also link into machine code from C, might be to hex, and so on. And then finally test code. So for this particular manual, the code will be tested by loading to 40K. PTK40A, and you run the program. This is for kit. So the next module will cover on how to operate together with PIC SafeLab. So looking at part D, how to create the project first. We go to the start page, okay, the main window. So the version right now is lower, slightly older than the previous one, version 3.20. So the difference is not much. Okay, so you can start by going to File, click New Project. So in Figure 3, and then choose Project. Okay, so the selection available here. So you need to choose whether the project is standalone, existing project, preview, user maker, library, and also some other option available, other embedded project, and then sample project. So for your level, you need to begin with standalone project. So standalone, whenever you click new project, new option available. So this is figure 4. So you can see from here, this is what happens when you click new project. So you need to set standalone project. Okay, go click here, select this one, better, and then standalone project, and then when you certify, click next. There are several steps that you need to follow. This one by using wizard. Okay, then select device. This one, once you have completed, when you click next, new step, which is step number 2. This one will require you to select which type of device you want to use, which type of microcontroller. Okay, so you need to choose mid-range, because this one, the PIC that we are using, belong to this group. Okay, so if you refer to figure 5, so you can see here, we have up to 7 steps. Okay, so choosing project, creating new project has been covered in step 1. Okay, so right now you are currently in step 2, selecting device. So you can see here, the family must be mid-range, and then you select device. So you can see here, okay, only 2 selection. This one for version 3.2. So later on, we can see the difference between the current one, the current latest one, and the previous one. And then once you have select this, click next. And then you go to selecting the correct programmer. So in that one, will be covered in step 3. Okay, so referring to figure 6, okay, the programmer comes together with the color coded. So you can see from here, for full, for beta, and also for nothing. Okay. So this one will meaning of every line. Every time you choose the programmer, the required programmer, it is come together with color coded. And then for hardware tool, that can be used either debugger or programmer. So this one I will show you later, whether we want to use debugger or programmer. Okay, so at also our hardware tool, you also notice a serial number. So below that hardware tool, they will also show a serial number. Okay. Below any tool that is connected to your computer. So if provided that if you have some kind of hardware tool connected to the hardware, to the computer, and then the last one, the next one, select PIC kit 2 programmer in figure 7. This one. This one, if you are using together with PTK40A. If you are not using PTK hardware, you are using PIC SimLab, so you need to select. But for this manual, it did not show. So we will see that in module 1C. So right now, if you are using connecting to PTK, so you need to select PIC kit 2. And then the compiler, which type of compiler you want to use. If your PIC is 8-bit, you need to use XC8. As shown here, as in figure 9. This is the compiler. That one belong to step number 6. Step number 6. And then step number select project name and folder. This one, the last one, step number 7. You can select the name, the project name, location, and other project feature as in figure 10. Shown here. Okay, so this one, step number 7. Okay, so inside this step number 5, you need to complete the name, location, and folder. You specify or you can locate. You can browse for folder location, and then you need to set the previous setting as the main project. And then this one, use project location as project folder. This one you want to select. You want to set the project location as the project folder. So every project will be placed inside this folder. And then the encoding, for example, this is the code. So what it does is that it just gives you representation in the form of color, font, pattern, syntax, and everything. The format that the program. So every project created during the lab session, you are required to save the project in the folder using your metric number on drive. This is for lab session, face-to-face lab session. If you are using your own PC, you can do anything. So for face-to-face, you need to put your folder on drive D, and then you name your project with your metric number. Okay. For example, we name this lab module 1B as module 1. Okay. So, and type the project name. The module 1 will be named as the project name, and then when you finish, okay, click finish. Okay, so this is the final step. This one, you replace it with module 1. Okay, so this one, when you want to use using lab face-to-face, okay, you write down the project name and then the project location. Okay, so if you don't want to type, you can browse, click this button and locate the correct folder, and then when you select the folder will be placed here according together. Okay, come together with the project name. This one. So it will display the folder and also the project name. And then need to set as main project, and then the encoding. Better use follow the example here. So when you finish, everything will look like this as in figure 11. So this one is version 4.10. So this is after you create the project, only project. Okay, so module 1. So this is the subfolder that is related to module 1. So you can see here, nothing yet, nothing happened yet. We did not see any kind of file. Okay, so this one will also will only enable the creation of project module 1. So other than that, if you observe bottom here, bottom window, so you can see, you can check. Okay, the PIC select is PIC 16F877A, and then the compiler would be XC8, and then the debug tool would be PIC kit 2. Some of the information, make sure that you check to see whether the selection is correct. And then that one will conclude the setting up of project. So how to write? For writing code, you need to follow part C, creating a source file. Every program, every code need to be written, need to be write on a file. We call it source file. So how to create a source file? Okay, so you go on the main window, follow from figure 11. This is after you create project. So make sure before you create a source file, you need to create project first. Okay, so from figure 11, so you refer to figure 12. You go to file, create new file. When you have click the new file, okay, a new window, a new menu will appear. So the step also included here. So right now you are at step number 1, choosing the file type. Okay, choose the file type. For your tab, for your session, you need to use C source file. Okay, select this one. The project name. Okay, so since the project name is module 1, better check. Okay, so you are at the correct module. And then click next. Okay. And then for step number 2, you need to set the source file name. Make sure here, you fill everything. This one is source file name. The name can be different from this one, from project, and also you can use the same name when you have complete that. But make sure other than that, extension must be C. And then the folder that contain this file, also the project shown here, it must be similar to the project file. And then click finish. Click finish. After pressing the finish button, window in figure 15. So this is what happened when you have successfully add the source file. A new file will appear here according to the name. You're naming your file module 1C. So this is the file that will be available. And then the file. Other than that, so this is the first method. We have also another alternative method. So this one just a repeat, from part C using another method, alternative method. So previously, you click file if you want to add source file, but the second method, you can also click here. Okay, so for this particular example, click source file, left click source file to select, and then right click. New menu will appear. Click new and then go to clicking main.c. And then after that, same option. After you have do this, same option will appear as in figure 14. It will take you to the same window as in figure 14. So after pressing the finish button, the window as in figure 15 will appear. So when you click finish, module 1C here will be displayed here. So this is module 1C. Okay, so for newer version, the file is not completely blank. It will contain some kind of template that will help you to write your program. So this is version 4.10. You see nothing, only blank file. Okay, but for later version, you will see some kind of template written in the form, some of them in the form of a comment. So this is the final together with the source file. So if you start the next stage, you need to write. You need to write your program, and then you can build. After you have finished writing the program, you need to check. So that one will cover in building process. So since you are using C language, the first step is to write down the pre-processor directive, which is some examples shown here. Hash define and also hash include. Okay, so hash define may contain some kind of declaration for specific identifier, and then for include, hash include may contain external file, location to an external file that is not related to your program. So what are the benefit for include one? if you are using, if you are writing different program but using some same process, okay, so you can include a file that have the process without rewrite everything, without rewrite anything, any rewriting on the each of the program. So that one will be easy. Okay, and then define also, you can declare this one is available on the first stage on the program structure, and then you go by declaring certain name of your variable, function, and the type used in the program. So you already know what is variable. So the function, maybe we will see in our next lecture. And then we have two types of variable other than previously mentioned in our lecture. We have global variable and also we have private variable. So global variable need to be declared outside the function. This one we will see later. And then local variable or private variable need to be declared inside the function. So again, if you declare correct setting for variable, so this one, why? Because every variable declaration will reserve their own storage size. So make sure you correctly define your variable. And then combination of this one is based on our lecture number 2. The content of program, operator, operand, variable, and then the flow of the program execution. So you go refer to part step number 6. All C program must contain a function named main. So this is where the program begin to execute. Okay. So every program, if you are writing, developing a program for PIC microcontroller in C, so the program must have main. Okay. So the syntax we will see later. The code, how the code template, how the program syntax return unit, that one we will see later. Okay, so you retype the program in example 1. This is example 1. Okay, so you can see the structure here, starting with include xc. So this is another file. So by including this file, it will save you time. So you don't have to define this one related to the definition of our microprocessor or pre-processor. And then this one already covered in our first lecture. So you need to define the configuration setting of the microcontroller. So you need to enable or disable frequency oscillator, watchdog, power timer enable, brown out, and then low voltage programming. So you need to enable or disable this configuration parameter. And then you go to define the frequency of the oscillator. Okay, so how you know the correct value is why you need to refer to the connection, the hardware. Okay, if you are connecting your microcontroller with 20 megahertz crystal oscillator, the value here must be 20. If you are using 8 megahertz, the value here must be 8 megahertz. The value must equal between software, hardware, so that the program can operate smoothly. And then you go for global variable declaration unsigned char. So this means that I and j is positive number ranging from 0 to 255. And then this is the main program. The main subroutine, we call it main. So you need to follow this kind of naming command. Type void space main space, and then you can put void. Okay, open and close bracket. So another one, the curly bracket, open and close bracket. Every code written before, after the curly bracket and before the closing bracket will be executed. So this one will contain the configuration setting for the microcontroller. So that one we'll see later. Okay, so we refer back to the step. Okay, once we have save the file and go to production build project. So if you are when you have successfully finished writing up the code, you need to test your program. Okay, starting by building the project. Okay, so how to build? You can refer to figure 17. Looking carefully, look very careful. So several icons on the top of the main window. So you need to click this one. Okay. If you don't know, you can refer to your screen. Okay. Just move your cursor on top of this icon, so you can see new information here. So that one is for building the project. So you need to click the icon. Okay. When you click the icon, it will compile the code here, code written here. So if the code is contain no errors, so you will see this on top of on the bottom, of the main window. So you can see green font. Okay, build successful. So this means that the whole project does not contain any error. So therefore, you can proceed to programming to microcontroller, or you can go for simulation. Okay, so you can also see figure 18. This is what happened if the program is successful. Build success. If error, so you need to go back to your program. You need to locate where is the error and then do correction. Okay, so exercise 1, you are encouraged to do it by yourself. Okay, so no need to submit anything. Ada soalan tak? Do you have any question right now before we proceed to figure to module 1C? Okay, tak ada soalan. So you can see clearly, you can observe the movement of my cursor. So we proceed to module 1C. So this module will give you introduction. As stated in objective, it will give you introduction to this software, PIC SimLab software simulator. Okay. So what is a PIC SimLab? It is a real-time simulator for development board equipped with MPLAB X or AVR GDB debugger. You can use it together with MPLAB X or AVR. Okay. So the supported microcontroller would be PIC, some of the AVR microcontroller. So you can also use with MPLAB, or you can also use with Arduino if you want to simulate the program to observe the output. And then you can also build circuit. So unlike PTK40A, you need to, if you want to observe the output, you need to make program according to the available function, according to the program output. Let's say if you want control motor, okay, so the circuit is already included here. Okay, so you just program. But if you want to control a certain function that is not included inside this PTK, so like for example, you want to control servo motor together with DC motor, and then you want to observe this, you want to transmit some certain information through serial. Okay, if that function is not supported, you cannot use this kit. You can only operate provided that the function included here is available. Okay, but for PIC SimLab, you don't have to worry about that. Everything is available okay, in spare part. Okay, what is spare part? That one I will show you later. So the main disadvantage that the device is not readily available. So if you want to operate certain function, you want to observe, you need to build the circuit. And then, for example, okay, like for example, if you want to monitor LED and push button service, push LED and push button, what happen? LED and push button function. Input, you want to observe input, and so you want to observe output. You can build, you need to build first the circuit, and then you can execute. After that, you can simulate. This one is the simple one. And you can also go for the complex one. Like for example, Ethernet shield, and also graphic display, model number I9340. This one controller for the TFT with touchscreen. So it support devices starting from basic up to the sophisticated one. You can view the available part in the software documentation. So we start first by looking at the procedure section. First one, you need to install. You can go to the link provided here, download, okay, and then once you have successfully download, install, then when you execute the program, this is the main menu. Similar like this. Menu. This is version. You want to know the version. You click this one. Version 0.8.9 to 10727. This is current version that I'm using. And then this is the control board, this is the interface. So for step number 3, if you have not installed MPLAB, you can proceed to step number 3. But right now we skip to step number 4 by doing this installation of the IC SimLab. Okay, once you have downloaded the software from step number 1, you go on, proceed to install. And then if you want the PLC SimLab to work together with MPLAB, another file, another program you need to include, you need to download. And the link is given here. Okay, so this link will enable PLC SimLab and MPLAB X integration. So whenever you execute program MPLAB, you can send the program to PLC SimLab. Then you can observe the output. Okay, so how to install the next software is the link, or we call it plugin. Okay, so looking at figure 2, figure 2, you go to the top menu, you click tools, and then you click plugin. Once you have do that, once you have done that, another window or menu will appear. So there are several tabs here. You need to choose downloaded. You choose downloaded, and then when you select downloaded, okay, this is the current situation. Okay, what contained inside downloaded section, you need to click add plugin. After you click downloaded, you go to click plugin, and then you need to locate the file that you have downloaded. So this is the file name. Okay, so you can see the extension is .mvm. You cannot install independently, so you need to install within the MPLAB X environment. Okay, so this is another language. Okay, so yes, cancel. Okay, okay, cancel. Okay, Spanish language. And then figure 5. So this is what happened. When you have select the file, click OK. And then this is the plugin. After that, after figure 5, you refer figure 6. This is what happened after figure 5. When you have select the compiler, the correct compiler, you go first by select tick here. Make sure the name here is PLC SimLab and MPLAB X debugger. If you are using this correctly, information related to that particular software will be displayed here. Then you go on to click install. So how to start up by executing? So this one, how to do program, how to do program and simulate your program using PIC SimLab. You start first by start up the program to execute. So like I said, before you do anything, if you want your program to work together with PIC SimLab, you need to start first by executing MPLab first. Okay? When you after you execute MPLab, okay, and then the window appear here, then you can proceed to executing PIC SimLab. Okay? The flow need to be followed. So this is so previously there are 7 steps. Okay. So step number 1 is the same like the previous module. Only different is step number 2. So if you refer to figure 7, this is what happened in figure 2. Okay. So this is for newer version. So you can see older version, like I said previously. Okay. So this is older version. So you can see only 2 selection. But for new version, so you can see another one, another new selection, which is 2. So you need to locate the axis in the menu. Okay, so check first. Right now the current step is step number 2, and then you define the correct microcontroller, and then okay, you tick first. Tick show all, then you can find the axis in there. If you do not tick, then the name here will not appear. Okay, so make sure you tick. Then click next. Okay, so once you click next, you can start by writing new program, provided that you have successfully create the project and then create the source file. So everything. So start from step number 2. Only step number 2 is required when you want to add, when you want to simulate using fixing that. Okay. For step number 1, 3, up to 6, similar like the previous one. So you need to include the selection here on step number 2. So you start by choosing project, and then for step number 2, you need to select. After that, you do the same thing. This one only included in procedure for creating project. For creating source file, similar like the previous one. Okay. Once you have compiled, okay, you have write the program, and then you compile, and then success. Make sure that the status must be successful, and then you refer to go to that window to select that window. Make sure that the setting you follow setting as in figure 9. If you are using 8 megahertz, so you need to change this to 8 megahertz. But our program is 20 megahertz of register, so you need to choose 20 megahertz. And then debug button also need to be pressed. Okay, so after that, you need to be a circuit. So if the program only concerned with also LED, lighting up LED, so you need to be a LED circuit. Because this one does not contain any pre-built, pre-assembled circuit. And then click debug. Okay, once the status building status is successful, you click debug. Okay, do this by clicking this button, this icon. Okay, so when you click this icon, status will appear shown here. If the linking is a success, the connection happen between MPLab and PIC SimLab. Another tab will appear here, the output status. So you can see PIC Sim tab will appear. It will appear only if the program is successful, so the communication has been established. Okay. The status will appear here. So when you see this, you can go back to this menu. But first you need to build the correct script first. Then you can observe the output over there. So this one, okay, when you click debug, another new menu, new icon will appear, new menu. So you need to, let's say for example, if you want to stop debugger, you want to modify your program, make sure to stop first. You click this one, stopping debugger. So once you stop, then you can go back, writing up your program, and then you do the same thing. Every time after you have modified your program, you need to build first, okay, and then debug. If you want to repeat, stop first, write out the program, build, then debug again. So you need to follow, repeat the sequence. And then this is the final version. If you want to exit from the program, just click disconnect debugger from the main selection here, debug, go to disconnect debug tool. So that one we conclude on the introduction part for teaching that. Do you have any question you want to ask? Ada soalan nak tanya? Okay, so no question. No question, so we proceed to the actual implementation. Okay, so make sure that the order first. So right now, we're going to proceed with demo working together with MP Lab, also PICC Lab. Okay, but without 40K, 40K you need to attend lab session. So the order first, you click execute MP Lab, and then you go to executing PICC Lab. So the first thing, you need to create project first. Okay, so as you can see here, okay, so this one already created. So I will remove first. I will remove first. Close. Close our project. So this is the default condition without any project. So you can see here empty. Go to file, new. Okay, already selected here. You click standalone. Click next. Okay, so right now, previously step number 1. So the current step is at number 2. You need to select device. So I can always use recently. This one provided that you have already do exercise, do the programming. You can select this one easy. If you want to use same microcontroller. But for first time user, you need to select where is the group, correct group for PIC16F. Okay, so you can go for baseline, you can check whether it is available or not. So if not, you proceed to make change. PIC16F 877A, this one. Okay, select. Okay, so right now tool. So this is what happen if you do not select or tick show all. Okay, only two options. No tool and simulator. If you tick show all, the option will increase. You can go by selecting pick simlab. Okay, so you can see here, pick simlab not enable. So you can go to cancel. The best thing to do is reset the whole program. You close the whole program, and then you restart again. Okay, then you go to PSC lab, execute the program. Okay, make sure that the debug here is enabled. You turn on the debug and then you check again. Proceed, repeat the step. Standalone. Okay, so you can see okay, problem happen PIC simulate so again okay, so again see what happen you can check first you can go for tool, check whether wait first. Okay, so the program is enabled already been installed so try again if you having the same problem you need to try again okay, so after third try okay, so you can see here okay, so you already know what are the problem that is going to be happen what are the problem that you're going to face so first for the first time is if the program PIC sim lab is not available so you need to repeat you need to restart the program by following the correct order okay, so right now we can go to the next one okay, so there are two function two compilers I go for the latest version and then this one the old type compiler so you can see right now we are at step number 5 and then next this one okay you can write down the project name we call it lab 1 okay call module 1 anything you desire okay provided that you do that in your own computer okay then you locate your project file okay so the project file is here lab intro so this is the project name open then the folder shown here okay together with lab number 1 and then so you can see the last stage step number 6 select set as main project and then the coding the encoding and then you go to finish okay. Click finish okay. Since I already developed the program I just uh, reload the program throw one okay. So you can expand the subdirectory okay. So this is what happened what contain and then you can see the cursor movement the mouse cursor okay, you can check the correct setting the device is PIC 16F and then the compiler is at X8 and then the debug tool will be HTML so that one so if everything is correct you can click either any page intro 1 source file okay. You can click source file and then you can right click new main.c type down the file name lab1 the extension must be in C the project name will be based from the previous setting which is project setting okay. So the name of the project if you're using module 1 so the name will be here if we want to put different locations so you need to set but prefer you do the same thing. You put everything on the same folder. If you satisfied, you click finish. Okay, since I already developed the software, so I just add existing item. So that one. Okay, so already included. Okay, so this is the file, the main file.c. Double click, and then you will be able to look the program here. Okay, so this is the configuration, setting, the include part, and then the microcontroller frequency, the main program, and then 3D and 4D configuration, and then this continuous looping. What happened inside this continuous looping? You can see here port D. Okay, we know that port D contain port A, port B, port C, port D, and port E. Okay, so we are using port D. So what is the range of port D? From it contain bit number 0, bit number 0, bit number 1, number 2, up to bit 7. So total will be 8 bit. So that's why you are writing up to 8 bit. So the first one, okay, so you can see I do some minor adjustment to the program. So port D, okay, so we go back one by one. This is the configuration setting. So the last one. So there are no global variable setting. So this is the main, the basic program. Okay. After main, so you can see here 3D. So before you want to use port, digital input output port, you need to set whether that particular port can behave as input or output. If you want to set it as output, you need to give zero value, zero. Okay, so the number must be 8 bit. If you want to use all, let's say port D contain 8 bit, so you want to set all the port as output, so you need to put zero. Okay, up to 8 bit. This one will make the port D behave as output. If you want port D to behave as input, let's say you want port D to receive signal from switch. So this means that output from switch will go into microcontroller, which is port D. So you need to set as input. So if you want to set input, everything must be set to 1. And then you go on to clear to reset any initial value inside port D. Okay, and then after that, the flow will proceed to continuous looping. Anything happen, return code and return between this bracket, inside this bracket will be executed continuously, because while true, while one, then there's no, the condition is always true. And then port D, what happened after that? Port D need to be load value of high. So you need to enable on. So why turn on LED? Because we are connecting LED to port D. So this means that we want to turn on the LEDs all bit. So we write down 1. And then wait for 1 second. And then I want to on and off. So put all 0 or 1 and all 0. Then wait another 1 second or 1000 milliseconds. So the program is basic. So make sure the setting is correct. And then you can go for, because we want to connect LED, so you can go to spare part. Okay. So this is the previous program. This is the previous program. Okay, so let's see what is the current program supposed to behave. You need to start by click build project. Okay, observe this bottom side, bottom window. So status here need to be a success. Okay, so you can see here what happened. If nothing bad happened, your program, the status will be changed to appear as successful. Okay, after that, you go on to click debug project. So this is the linking process between MPLab to this thing that happen. Okay. Again, observe bottom here, bottom window here. Okay, do one. Okay, since successful, so we need to expect another something to happen. Okay, so you can see here. Okay, another new tab exists here called Pixim. So when this happens, so this means that the program has been successfully transmitted to Pixim. So you can see output here. Okay, so it is blinking for 1 second, 1,000 millisecond. Okay, so if you want to this one right now you can see all pin inside port D, starting from port RD0 up to port RD7, all LED connected to port D. Let's say if you want to change it, you right click properties, you can change here. Let's say for bit RD0, you want to connect to RD1, you want to connect to pin RC or RB or RA, you can choose from here. Let's say I want to put RD0, I can put it to any bit I wish. Okay, so let's say I put to RB1. Okay, and then the active. So if you click here, you can see two options, high and low. What is active high, what is active low? So right now, this one will be explained detail later, but right now, we want the LED to be turned on during high. So we put it high. Okay, what is high? What is high? So high means 1. Okay, we want the LED to be turned on when we transmit 1. Okay, or we give high value. Okay, if active low, in order to turn LED, we need to give 0. So you can see here, RB1 is not turning on. Why? Because we are not setting any pin on RB1. So you can change back to RD1. Okay, select here RD1. Okay, so everything like that. And then if you want to modify your program, okay, you go here, select here, finish debugger. Okay, you stop the debugger. Let's say I want to increase the speed. Change it to 300 millisecond. Okay, build first. Okay, be successful. And then you can go to the second one, debug. Okay, observe here, okay, since Bitstream already appear here. So, okay, be a success. Okay, so you go to Pixim, so you can see a run target. And then you can observe blinking faster than the previous program. And then let's say if I want to do another changing bit number 7 on the 8 bit, I want to make it 0. And then this one I want to make it 1. So build, wait until success, and then debug. You can see here the success. Okay, run again. So you can see here Okay. Alternate direction, on off, on off. If I want to make it a little bit slower, so I can go for 5,000, 6,000, according to your desired value. Okay, sorry, you need to stop first. One. Okay, run target. Okay, so you can see here. Let's say if you want to add the component, so you can select from here. It can be input, it can be output, it can be others feature. You can select between this option here. Let's say if I want to add another one, I want to add another output, 7 segment display. Okay, I select first, 7 segment. Okay, click. Then even though you did not see anything, okay, you need to click anywhere. So the 7 segment will appear here. If you want to remove, right click, delete. You want to add another one, jumper wire. You want to remove, delete. Let's say if I want to observe the output pattern, you can locate. Okay, so you go back to the main window, click oscilloscope. This one, if you want to observe the waveform pattern from port D. Okay, so this one can only accommodate up to 2 channel. I want to observe D0 and then D1 up to 2 bit. Okay, so build first, then debug, run target. Okay, okay, so running at 1 millisecond. So you can see here, this is the waveform pattern at sampling 10 millisecond. So you can see high and low. You can also increase the time division. This one, okay, you can make it faster, slower. Let's say I put 50. Okay, 50. Nothing happen. Try to make it 100. 100. Okay, so you can observe. Okay, let's say make it slower. 1 second. 1,000 millisecond. Need to wait. Okay, 1 second slower. Oh, sorry. So this one, limit, the limit here, up to 200. So make it faster. And second. Okay, so you cannot go up to 1 millisecond. And then stop the debugger. So I think that's it. That one will conclude briefing for lab 1. So next week, we're going to proceed to lab number 2, input and output. So you need to go to PC, download the lab module. Okay, so before we stop here, do you have any question you want to ask? So no question. So if no question, stop recording first.